Scenario, which is the title of our lesson for today. So we'll do scenario number 1. It's going to be a strong acid, strong base titration. Strong acid, strong base titration. What that means is that I have either a strong acid solution to which I'm adding strong base and discovering what the pH is along each addition, or it's the other way around. I have a strong base to which I'm adding a strong acid and, again, calculating the pH as we proceed along the titration. So in this case, what we're going to do is we're going to add base to a strong acid solution. So strong acid, strong base. So we will follow the progress of titrating 50.0 milliliters of a 0.200 molar HNO3, nitric acid, strong acid, fully dissociated, with a 0.100 molar NaOH. By calculating the pH of the resulting solution after specific volumes of NaOH have been added. So we're going to follow the progress of titrating. We have 50 milliliters of a 0.2 molar HNO3 solution sitting in a beaker, and to that we're going to add various volumes of this 0.1 molar sodium hydroxide, different volumes, 10, 20, 30, 40, 50 milliliters, and each time we add these volumes, we're going to stop and calculate the pH at that point. We want to follow the progress of the pH to see what happens, and that's what we're going to plot. So this is going to be a bit of a long problem. Like I said, it's going to occupy most of the lesson. It is very, very important that I don't want you to get the idea that it's actually this complicated. It's not that each titration problem is going to take this long. It won't. We're doing it simply so we actually expose every aspect of a titration problem so you understand the chemistry, and hopefully by understanding the chemistry you can move these problems along much faster when you actually do them. But since we're introducing them, we're going to take our time and do it properly. Okay, so let's go ahead and start with our initial situation. Our initial situation is no NaOH added yet. So with no sodium hydroxide added yet, all we have is this 50 milliliters of a 0.2 molar HNO3 solution. Well, this is just HNO3 is a strong acid. It's just we want to calculate the pH of this solution. So we do what we always do. Let's check what our major species are in solution. Well, our major species are H+, because it is a strong acid, fully dissociated. It is the nitrate ion, and it is the H2O. That's it. Well, strong acid, water, weak acid, the Ka is 1 times 10 to the negative 14. Strong acid, there is no Ka. It's, through the roof, a huge Ka. Therefore, this one, the hydrogen ion concentration, is pretty much the hydrogen ion concentration of the nitric acid because it's fully dissociated. Here, the HNO3 is fully dissociated into H++ NO3-. That's why we have these major species. It's floating around freely in solution. So a 0.2 molar solution of this produces 0.2 molar of that, 0.2 molar of this. So the hydrogen ion concentration is 0.200 molar. That implies that the pH of this solution is 0.70. So we have our first pH.